Hi everybody, welcome to another video in Math 1332, section 2.2. Subsets. Subset, every element of set A is also element of set B. If that is the case, then A is called a subset of B. So A is a subset of B. So A is itself is a set. So a set is a subset of another set. And we use this symbol to denote a subset. So for example, we can say the set of 1 and 2 is the subset of the set of 1, 2, and 3. Because every element in here belongs there. Right, we can also say 1 and 2 is a subset of 1 and 2. Because by definition, every element in here belongs to every element in there. And if it is not a subset, we use this symbol. So that is a subset. Now, a set A is the subset of B and not equal to B, then it is a proper subset. So we write this earlier, right? We can also write it is a proper subset. Because they are not equal. We write 1, 2 is a subset of 1 and 2. That is correct. But if we write 1, 2 is a proper subset of 1, 2, that is not the case. Right? So that analog to the case we say, for example, 3 less than or equal to 5, which is good. 3 less than or equal to 3, which is also good. 3 less than 5 is good, but 3 doesn't less than 3. So kind of like that. That's why we use this symbol. Right? So 1, 2 is not a proper subset of 1 and 2 because it doesn't have equal. So the line below denote that they can be equal. So the proper subset meaning they are subset but cannot be equal. Right? And we write this symbol. Right. Here we have a properties. Every set is the subset of itself. An empty set is the subset of every other set. Right? So to write it out, A is the subset of itself. Not proper subset. Proper subset will be wrong, but just a subset. And empty set is a subset of every other set. Right. Now, let's find all the subset of the set A have convolve. Well, first of all, by this definition, the set convolve itself is a subset to itself. And then an empty set is the subset of A. So we have two of them. There will be two more, the set of only one element. So it is a subset. Right, so there are 4 subsets of A. Now, decide whether, decide if the statement is true or false. We have a few examples here. 1, 3, 5 belong to, is a subset of 1, 3, 5, and 8. So this is true. Because each element here belongs to that set. AB equal to A and B, but not the proper subset, so this one is false. If they have the equal sign, it will be false. It will be true, but since there's none, false. I will write that a set of A and B is equal to A and B. So every set is a subset to itself. So this one is true. So in comparison, that will be false. X is an even number less than 10. And that is subset, proper subset of natural numbers. So this is true because natural number we have from 1 to 10 and then more than that. So every element here belongs to every element there, because I just use the proper symbol. So this is true. Next, RST not a proper subset of SRT. They are equal. So if I use that symbol, a subset, that could be proper subset, that could be false. But it is not a proper subset, therefore this is true. Yeah. So not a proper subset, they are equal. Right. An empty set is a subset of everything, so this is true. 5 is an element to that. It's just wrong symbol, so it's still false. Because if we want to write correctly, we have to say 5 is an element of 1, 2, 3, 4, 5, 6, and 7. So this is the proper way to do that. Yeah, it's just wrong symbol. Or we can say the set of 5 belong to, the subset of 1, 2, 3, 4, 5, 6, and 7. So this is also true. But not that. That one false. Right, next. ABC is a subset of ABCs. This is true because every set is a subset of itself. Next, that one's false. This have one member of an empty set. This member does not belong to that set. This is an empty set. Empty sets had no member in it. So this one false. So in general, if you have more elements, it cannot be a subset of something less element. Once again, this empty subset does not belong to that empty set because empty set does not have anything. Alright, next, find the number of subset and the proper subset of the set ace, king, and queen. Right, I'm just going to list them. Subsets. So we start with the set of all 3 of them. I'm just going to use abbreviation. Ace, king, and queen. And now let's say the set of only one. A, king, or queen. Now the set of 2. Ace, king, a queen, and queen and king, or king and queen. And finally, an empty set. So let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8. So this set they are a subset. Now on to proper subset. Proper subset, pretty much everything here except for the set itself. Proper subset cannot be equal, so we just excluding that, everything else stays. And originally there's 8, take out itself, so only 7. So we say there are 7 proper subset. So, and so in general, how many subset and how many proper subset do we have? So let n be the cardinal numbers of a set A. So A have n members. So then the number of subset equal to 2 to the power of n, and the number of proper subset equal to 2 to the n, pretty much that, minus 1. Right. So now that we have the formula, let's go back to some of the previous example and see how that works. So this set had 3 members, therefore the number of subset is equal to 2 to the third power. So 2 times 2 times 2 is 8. So exactly there are 8 subset. Now this one, proper subset, so 2 to the 3 because there are 3 members, minus 1. So I have a minus 1 is 7. So indeed they have 7 proper subset. On the first example, we have this set have 2 members, so we have 2 to the second, that is give us 4. So we have 4 subset of A, 1, 2, 3, and 4. Right? So just 2 to the number of members in the set. If it is subset, a proper subset, we have that number minus 1. Right, look at this example. Find all proper subset of spring, summer, fall, and winter. So there are 4 members in it. So the number of proper subset is equal to the 4 because there are 4 members there, minus 1 because it is the proper subset. So 2 times 2 times 2 times 2, 4 times, that's 16 minus 1, 15. So there are 15 of them. We just need to list all 15 of them. Right, first, if we want to list them, the first one is easy. An empty set is a subset of everything. So that's 1. Next, we will list the set that have exactly 1 member, spring, summer, fall, and winter. Now we list the set that have 2. Systematically, we just keep the first one, spring, and then we take 1 of the second, spring, summer, spring, fall, and spring, winter. And then we pick the second one. If we go back summer, spring, we already have that. So whenever we pick one, just keep everything moving on the right. We don't never go back, just go forward. So we use summer, and then we gonna pick summer, fall, and then summer, winter. And then we're done with that. We go to next one, fall, and the only thing, one option left, are winter. So if we pay attention, this one we have cardinality of 0, this cardinality of 1 member in each, and this we have 2 members in each set. So cardinality of 0, 1, and then 2. Now next, there are 4 of them, we can still choose 3 of them. So here we say a spring, summer, fall, and then so on. But a little more systematic way, so we will not lose anything. So spring, summer, and fall. So what we see here is we don't have the last one, so we just skip the last one. Now we skip the third one. Spring, summer, and winter. Now we skip the second one. Spring, fall, and winter. And now we skip the first one, summer, fall, and winter. And this we have cardinality of 3. And there are 4 main members. So if you count, we have exactly 15 proper subset of this set A. Right. So that's how we list them. So in that case, we start with cardinality, which is the smaller one, and increase and try to list everything in that case. Right. Now let's take a look at one more example. If we have the set of A, B, C, D, and E, how many members, how many subsets do we have? So number of subset of this equal to 2 to the number of members, or 2 to the cardinal number. This 5 case 5. 2 to the 5th power is 32. That's 52. Sorry about that. 2 to the 5th power is 32, not 52. Right. With that, we finish section 2.2. See you in another video in Math 1332. As always, thank you for watching.